Hello, in this video we're looking at MEI FP1, the May 2011 paper question 6, which is on proof by induction. The important thing about proof by induction is that you are very systematic about it. Take this step by step without cutting any corners. So, the first thing to do is to consider the case when n equals 1. When n equals 1, the left-hand side is equal to 1 and the right-hand side is equal to 1/4 of 1 squared times 2 squared, which is also 1. The left-hand side is equal to the right-hand side, so the result is true. For n equals 1. The next step is to assume the result is true. For n equals k. That's the same as saying that the sum of 1 plus 8 plus 27 plus all the way up to k cubed is equal to 1/4 k squared k plus 1 squared. That means that the sum up to the k plus 1th term is the sum up to the kth term, which we've just assumed, plus the k plus 1th term. So all I've done is added the k plus 1th term, k plus 1 cubed, to both sides of the equation. It might be worth at this point just making a note of what you're aiming for, but making sure that this is clearly aside from your proof and not part of it. We're aiming to get this result with k plus 1 instead of n. So that would be k plus 1 squared, k plus 2 squared. And I'm putting that as a very clear aside. Okay, the first thing to do is to deal with that fraction. So I'm going to take out a fraction of 1/4. And that means that I've got 4 lots of k plus 1 cubed. Just check that that line is equivalent to the line above. Now I can look at what's in both terms. I've got k plus 1 squared in both, and if you look up here at what I'm aiming for, I want k plus 1 squared, so that's good. So I'm going to take out 1/4 of k plus 1 squared. Whatever you do, don't try and multiply out that whole expression, because you're going to end up with a quartic that you then have to factorise, which is no fun at all. So my first term has k squared left, and my second term has 4 and one of those k plus 1s. Now I can't do any more taking out of factors. I am going to have to multiply out what I've got there. That's k squared plus 4k plus 4. And glancing at what I'm aiming for, I can see that that is indeed k plus 2 squared. Now I'm going to write that out a little bit more pedantically as k plus 1 squared, k plus 1 plus 1 squared. But that is the result that I need with k plus 1 instead of n. So I can now do my conclusion. But this is the given result for n equals k plus 1. Therefore, if the result is true, for n equals k, then it is true for n equals k plus 1. Since it is true for n equals 1, which we proved at the beginning, it is true for all positive integers n. Now let's have a look at the mark scheme. It's very important that you are aware of exactly where marks are given for this type of question. There is a single mark for all of this at the top dealing with the case n equals 1. There's then an explanation mark for this assume result is true for n equals k. Notice it's not assuming that n equals k, we're assuming the result is true for n equals k. There is no mark for this line here, but it's a good line to put in because what it's doing is translating that assumption into algebra. There's then a method mark for adding k plus 1 cubed to both sides. There's another method mark for extracting the factors of 1/4 and k plus 1 squared, and you can do that in one step or two. Depends how confident you are on your algebra. There's then an accuracy mark for getting down to this point here. We've then got two further marks for your conclusion, and those are dependent on the previous work being correct. There's a mark here for saying that this is the given result for n equals k plus 1, therefore if it's true for n equals k, then it's true for k plus 1. And that is dependent on the previous accuracy mark. And the final statement, since it is true for n equals 1, it's true for all positive integers n. And that is also dependent on the previous explanation mark and also on the B1 mark at the beginning. It's also dependent on everything being correct and no fudging of anything. So that final mark is also dependent on everything being perfect. If you want to find videos of other questions on this unit or on other units, please visit the Further Maths Support Programme's website. Goodbye.